All right, hello everyone and welcome. I hope you all had a nice weekend and are enjoying this strange weather day today. It's a nice weather day, but a little strange for February. I guess can't complain too much. Want to talk to you about the schedule real quick before we hop into today's topic because there's something very important coming up next week, which is our first exam. So we are right here. Today is the 3rd of February. We're going to introduce one more topic this week, and then next week on Thursday, so Thursday evening next week, you'll all be hopefully taking the first exam. And so that means a few things. That means that next Monday when you come here, I'm not going to be talking about anything new. I'm actually going to be wanting to review old stuff in preparation for the exam. I've also posted some materials for you to start prepping for the exam on Canvas that I wanted to make sure you're aware of. For starters, this first page here is just a list of kind of general exam instructions. You can take a look at it if you want to, but I'm going to go over this in class on Monday, so don't worry too much about it for right now. I'll make sure next week that everybody knows exactly what's going on in terms of where to go and when to be there and stuff. But I do want to make sure that you're aware of these two items here. This first one that says past exam questions is a Canvas quiz, and it contains, as it says, questions from past exams. These are all going to be like multiple choice, fill in the blank style questions. And it's just a practice quiz. Does not count towards your grade. Is entirely intended to help you study. So if you feel like you got it, you don't have to do it, but a lot of students find this is valuable practice, and that's what it's for. It's for you to practice and study and get ready for the exam that's coming up. The second thing here, Exam 1 coding prep. This is going to take you to a repository, just like for the assignments in the studios that you load into Eclipse. And this contains a whole bunch of coding practice problems. These have also are from past exams. So every problem that you see in this coding repository is taken from a past exam. They are going to require you to write code. So you're actually going to be expected to write code. You will also be expected to write code on the exam next week. So these problems are to give you a little bit of taste of what that might look like, what kind of code you're expected to write, what kinds of examples you're expected to write, things like that. So for next Monday, when you come in, I'll spend a few minutes going over the basics for the exam. It probably won't take me longer than 10-15 minutes just to kind of go over logistics and stuff. The rest of the time is going to be dedicated to review, and I really hope that you will bring questions to me to do. A lot of times what that means is asking me to go through some of these coding prep questions. So I hope that you have a chance to maybe take a look at those over the weekend or something, and then if you get stuck on one or you just want to see me walk through one, bring those questions in on Monday next week, because that's what we'll be doing here. And Monday next week is just doing as much review, as much prep for Exam 1 as we possibly can. Any questions about logistics, exam stuff before we hop into today's topic? Cool. Awesome. Let's talk about arrays then. So arrays are the main topic on our agenda for today. Just like last time, I made a little review, set of review problems for us to go through arrays. So it's already on Canvas. I put it up there this morning. You'll have to import it into Eclipse, just like you do for all the studios and the assignments. I hope that process is getting a little more familiar to you. You're getting kind of used to it. You're going to do it a bunch by the end of the semester. But if you're still having trouble with it, definitely let me know. Come talk to me after class. We can help get that figured out for you. I'm going to go ahead and pull up Eclipse, though. This is the review repository down here at the bottom that I want to work with you today, starting with just kind of some high-level conceptual questions, and then we'll do some practice problems. Is there a question in the back?
Yeah, so trying to import it, and then it says there's no project found.
Yeah, somebody else showed that to me a little bit earlier, and I'm genuinely a little bit confused about why. I didn't hear this problem at all last section. Are a lot of people having that problem? Most people are having that? I don't know what happened. Nobody told me about this last time. So I don't know if that means it didn't happen. I'm confused. I am legitimately confused. I also tested this myself, like before class. I loaded it up on my computer and it took off. So I feel like I did some. I mean, I don't know what the problem. Maybe I did something wrong. I'll take the blame for it. I don't mind taking the blame for it. I don't know how to fix it right now. I'm sorry about that. I can try and take a look at it after class and see if I can figure out what I did wrong, but I don't want to waste a bunch of class time on that right now. Did you have a question?
I was just gonna say I tried importing with the smart quality.
Oh, did that make a difference?
It did go.
Smart import?
Yeah.
Okay, that's a good tip. Thanks for the heads up. Maybe if you're having trouble, you can give that one a try and see if that fixes it for you. Thanks for the heads up. Thank you. Yeah, sorry about that. Sorry I don't have the fix for that right now, but I definitely will take a look at it after class. Thanks for bringing it to my attention so that I can get that fixed up for you. Okay, let's start with some high-level conceptual questions. Again, I'm asking these questions, under the assumption that you've at least taken a look at the prep work before coming to class. That being said, I don't expect you to be experts, right? You're new to this, and this is kind of a tricky topic, so don't feel bad if you don't immediately know the answers to all of these things. These are, kind of the high points, right? These are kind of the main takeaways that I'm hoping you get out of this section. So let's start by talking about how we create an array. And before I do that, actually, let's just talk a little bit about even what arrays are and why we're even talking about them in the first place. Arrays are an example of a collection of things. So we've been using variables a lot, and we're not going to stop using variables, but the variables we've been using so far represent one thing, one piece of data, one very small piece of data. It's a single number, a single string, a single Boolean value, right? It's just one value, though. It makes a lot of sense for us to be able to talk about things in terms of collections. So for example, if I had an application that was tracking the high temperatures, the daily high temperatures over time, right? You could imagine that I would have a collection of temperatures, a whole bunch of them, not just one, but a whole bunch. And I would want to refer to that collection as one unit, right? And not have to refer to each of those values individually. That could get very tedious very quickly. So arrays are not the last collection we'll see. We're going to see some more collections later on, but certainly one of the most commonly used collections. And let's say I want to make an array that contains integers. Okay? First thing I'm going to do, I want to make an array that contains integers. I type the word int. What do I type next to indicate that it's not just an int, but it's an array of ints? Brackets. So square brackets. Anytime you see square brackets in this class, I want your brain to think array. There must be some kind of array going on here, right? There's probably exceptions to that rule, but for the most part, the vast majority of the time, when you see square brackets, something with an array is happening, right? That's a pretty big clue. So I think that's important to remember as well, right? If I see this just by itself, that is one int. If I see this with the square brackets, this is a type, right? That I would say is an integer array type. That's actually what I would refer to that as. The next thing is I'm just going to make up a name for this array, and there are two ways to make arrays. I'm going to start by making an empty array. So I'm going to call this empty array, followed by the equal sign. What comes after the equal sign if I'm making an empty array? Does anybody remember? It's a three-letter word. New, that's right. The new keyword comes next. You can see Eclipse recognizes this word. It's an important one. It's in purple. That means Eclipse knows what I'm talking about. That's a good sign, usually, that Eclipse knows what I'm talking about. And afterwards, I'll type the word int, and I'll put those brackets again. But this time, I have to put something inside these brackets. I have to put a number in there. So I could put 10, or I could put 5, or 100. I can put whatever number I want. What does that number represent? I think I heard somebody say it. How many things? How many things are in the array? The size of the array. So if I have 100, that means that this is going to be a collection of 100 things. If I have 10, then it's a collection of 10 integers, right? And this is important. Once I do this, that array is going to be that size for the entire rest of the program. I cannot change the size of the array later. This is the one chance that I have to specify what that size is. If I want to add things later, I can't do it. If I want to take things out of the array later, shrink the array down, I can't do it. Question?
Is that going to say that the index is going to be 0 to 9 or 0 to 10?
we're getting there. Actually, you can see those are my next questions here. I love those questions, though. You're thinking about exactly the right things. Love it. All right. So this is going to create an empty array with 10 things in it. Now, I've been saying empty, but does anybody actually know what would be in this array? Zeros. Yeah, it'd be all zeros. It'd be all zeros. So not truly, zero is something, right? Not truly empty, but when I create an array like this, it's just going to fill it all with zeros. That's probably not what I want. Maybe in some cases I need a bunch of zeros, but in most situations, probably not what I want. We'll talk later about how we can fill it with stuff and make it not empty anymore. But let's take a look at the second way to create an array. So I'll make another integer array, sure. This time I don't want to make an empty array, I want to make a filled array, an array that has stuff in it at the very beginning, not just zeros, but whatever numbers I want. So what am I going to start typing after the equal sign here if I want to make sure that there's stuff in my array? Curly brackets, good, I love that. Last section somebody called these squiggle lines, and I think that's a great name for them, but the technical name for them is in fact curly brackets, curly braces. Yes, we're going to use curly braces, a pair of them, because they always come in pairs, and then whatever values I want to go into the array, I can just use a comma, a list with commas in between to say exactly what values I want. And so this will create an array that has exactly these four values in it. It has exactly those four values in it. And that means that the size of this array is also going to be 4. It's going to automatically say, oh, there's 4 items here, then this is an array of size 4, and put those things in there for me. I can make this as big or as long as I want to. It's up to me to decide, do I need an empty array or do I know what I want to put into the array? That's my choice, but we have the option as the programmer to do it both ways. They both come in handy in different situations. Yeah. Any questions about this part so far before we move on to the next question on our list? So let's talk about indexing. Somebody was asking about indexing before. Can we just get a basic, definition of an index? Can somebody tell me just in a sentence? What is an index? What is it? Position? Yeah, I heard the word position. I love that. Address is another word I might use to describe. So remember, we're talking about a collection of things, right? If I want to access one out of the collection, then I need to be a bit more specific, right? If I just say, show me the filled array, well, that's everything. That's the whole collection. So if I want a single value back out, I need to use what's called an index, which is a position, or an address. You'll hear me use all of those terms kind of interchangeably when dealing with arrays. And these are quite literally numbered buckets. So every one of these elements has an index associated with it. The first index of an array is what? 0. And that's a big one. A big thing to remember. We as humans like starting from 1 when we count. We like to go 1, 2, 3, 4. Computer scientists, however, like to go 0, 1, 2, 3, 4. We like to start counting from 0. And there are lots of reasons for that. I think it's more of a history discussion than anything to describe why that is in fact the case. The more important thing is just to remember that is the case. We start counting from 0. The first index of an array is going to be 0. So this 8 is at position 0. And in fact, if I wanted to retrieve this 8 out of that array, I could do that. I could say filled array brackets 0. Right? That will grab, that's saying go to the collection called filled array, grab whatever element is at position 0, and then what do I want to do with it? Do I want to print it out? Do I want to store it to a variable? I mean, that's up to me. I can do whatever I want to. Let's just say I want to make, a variable. And just to kind of check ourselves, make sure that things are working the way that we expect, I will print it out just to make sure that I get the 8, right? And I'm not getting the 6 or the 3 or something weird like that. So, okay, I run this little example, and there's my 8. I got it. I got the 8 back out. So the first index is always going to be 0. What's the last index? Or maybe I should phrase this question a little bit differently. If I have an array with length n, what is my last index? N minus 1. And that's because of the fact that we start counting from 0. If there are 4 things in this array, right? 0, 1, 2, this is at position 3. There is no position 4. Yes, there are 4 things in this array, but there is no index 4. The last index is 1 less than that at position 3. So if I wanted to, retrieve the last value out, I could do a similar statement, say filled array at 3. And when I run this now, hopefully I'll see, all right, there's my first element, and there's my last element of the array. However, I kind of have a little bit of a problem with this, right? Because if I come back up here and, let's say I want to do something like this. What's the problem? What's the problem with my code now? This part looks okay to me. I don't have an issue with that, right? But this one, I'm saying, the last, I've called this element last, and I said it's at position 3. Well, that's not true anymore. That's not correct anymore, right? The last element is now this guy, and he's not at position 3. I don't know what number that is. I can figure it out, though. And that's kind of the point I'm trying to make. Instead of saying, grab the value at the last position by putting the number in there, by putting the index in there directly, we actually can compute that and know exactly what it is. Or we can let the computer figure it out, I guess is a better way of saying it, right? By doing filled array dot length. So that gets me how many elements there are, right? And then we just take 1 away from that. Notice that whole expression is inside of those square brackets. So that means that whatever size this is, I'll just get that size and subtract 1, and it should get me the last element. It should get me that 11 back out. Right? Boom, there's the 8, there's the 11. If I add more on there, right? Add some more numbers, run it again. Boom, it automatically updated. I didn't have to change anything. That's great. That's what I want as a programmer. I want code that's going to work in more situations, as many situations as possible. Not only that, but let's take a look at, maybe an opposite example. What if I decide to come in and just chop a bunch of these off? Make this array shorter. Well, if I take the length and subtract 1, it still works. But what if I tried to do it the old way? What if I tried to do this? Now we got a problem. Now we got a problem. There is no position 3, right? Before there was a position 3 and the code worked, but my array changed and there is no position 3 anymore. So when I run it this time, we see, some big ugly red text. And this is when people kind of start to panic a little bit. And I understand this is usually not what you want to see, but I would encourage you to get used to mistakes happening. Get used to dealing with problems. We are humans. We make mistakes. That is a fact. We are never going to be able to do things exactly perfectly, at least not on the first try, usually. So accept that mistakes are going to happen and try to use this information to help you figure out what the problem is and fix it. It's actually trying to tell us what the problem is. Right here I can see it says array index out of bounds exception. So it's quite literally saying you went out of bounds. You went over the end of the array. You tried to access a number that is not there. Doesn't exist. The array is not that long. And if I scroll over a little bit more, it'll even tell me. Index 3 is out of bounds for length 2. So the array had 2 things in it, and you tried to access an element at position 3. I can't do that. It's too big. Can't do that. Furthermore, this guy right here, this line, that's highlighted, ends in :15. It's telling me where this problem happened. So in this example, it's pretty obvious where the problem happened, right? But if you imagine a big, long chunk of code, you see this message, you're like, where did that happen? Where's the problem? Well, I can click on this, and it'll take me right to the line where that error happened. And so now I know that the problem is either on this line, or it could be, you know, something that happened like right before this line maybe it's affecting it, but it's the right ballpark. I know I'm in the right neighborhood of where the problem is, and I can look for it and fix it. But, you know, to get back to the point at hand, the good way of doing stuff like this is to always ask the array how big it is. Even if you know, I know for a fact this array has 10 things in it, still better to use .length, because you don't know if that array is going to change in the future. You don't know if you're going to need to add things to it in the future, right? This will always work, even if that's the case. Any questions about that? Okay, so this is how we extract stuff out of an array. I grabbed the first element out of the array, I grabbed the last element out of the array. How do I put stuff into an array? Well, we're just gonna flip it a little bit, right? Remember that I made this empty array up here. It's all zeros. Let's say I want to put something into this array. I can say empty array at 0. That's how I would read that. Empty array at position 0 is equal to whatever integer value I want it to be. It's going to take this 7 and insert it into this array at the specified index. So now instead of seeing a 0 at position 0, I would expect to see the 7. In fact, you know, it wouldn't hurt to verify that by running another print statement real quick. And printing out the value at position 0, like so. Let's see, oh yeah, it's 7. It's 7 now. Everybody with me? Any questions before we move on to the next topic? All right. The next topic has to do with traversing arrays. So let's talk about this part first. What the heck does it mean to traverse an array? What am I actually doing? We're running, yeah, exactly. I mean, it's not wrong, but in this context, traversal means I'm going to visit each element of the array, usually once. So I want to look at each value of the array one time. That's what an array traversal means. So, you know, what coding structure do we use to do that? Does anybody remember? From the prep work? Yeah, in the back. For loops, yeah, it could be any loop. So if you said while loop, I also would have accepted that answer. But I think for loops just work so well. Very complementary to working with arrays. Let me start by actually trying to do a little bit of more justification as to why this is even necessary in the first place. Let's start with a very simple example. Let's just say I want to see the contents of an array. I just want to see all the values. Right? I just want to see what they are. Your first inclination might be to just print out the array, and that's not a bad inclination, right? I might print out this empty array and expect to see the value 7 followed by a bunch of zeros by doing so. But if you run this, you'll see that actually we don't get that. We get this. That's not what we wanted. That's actually not very useful to us at all. If you see something that looks like this, you've made a wrong turn. This should be an indication to you that I need to go back and put in a loop and do a proper array traversal, right? What are we looking at here? In case you want to know, it's not useful. It won't be on an exam, I promise you. This number is quite literally where on my computer this array physically is. I would expect you to see a different number than me. I'd be very surprised if you had the exact same number as me here, because your computer is different from my computer, and the array is going to be in a different spot on your computer than it is on my computer, probably, right? And if it's not, then we should go play the lottery after this, because that's some good luck right there. But this is not what we want. If I want to see the contents of an array, I can't just print out the array directly. I have to visit each item in the array and print out each item one at a time. I have to do an array traversal. So let's do that. For loop was mentioned as being a tool, and I think that's absolutely the right play here. In fact, the loop that I'm about to write is one that I've written so many times, a bajillion times. You're going to write a loop like this in this class dozens of times probably, right? It's a very, 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 very common tool. So I'm going to make my loop variable. I want to start, at the beginning of the array and go to the end of the array. So that means that starting at 0 seems like a good idea, since that's the first index of my array, right? I want the index to go up to, but not including, the length of the array. So we would say something like empty array dot length here. And then I want it to count up by 1. Think about what this is saying. I is going to start at 0. It's going to count up by 1 until it is greater than or equal to the length of the array. That's going to work out very nicely for us, right? If the length of the array is 3, that means that I can be 2, but I can't be 3, right? Because 3 is not less than 3. That would be false, and that would quit the loop out. That's good. That's what we want. As far as for what goes in here, I mean, we can put whatever we want in here, right? But just to keep things simple for now, I'm just going to print out each element that we come across. So I'd say empty array, and pay attention, I'm not going to put a number inside of there. I'm going to put I, right? So the first time through the loop, I is 0. 0 gets plugged in, and I print out the value at index 0. Next time through the loop, I is 1. I plug 1 in here for I, and I print out whatever value is at position 1, and so on, and so on, and so forth. And so if I run this guy here, we can see that, okay, here's the 7. That's the very first element that we put in, right, at position 0. And then here's all the zeros that come after it. Should be 9 of them. Right? It looks like it works. And if I want to print out a different array, well, guess what? It's the same loop. Just change the name of the array, right? If I want to print out the filled array instead, I can use the exact same loop. Just change the name of the array, and boom. I'm now going to print out the contents of the filled array, which is just 8 and 6, instead of the other array. But I actually want to do, one better. I'm going to make this array a little bit longer, just to make this example a little easier to follow. And I want to walk through this in the debugger with you. I think it's very important, especially when learning new concepts, walking through the code one step at a time and seeing exactly how it works. Very useful, very beneficial. So I'm going to put a breakpoint on line 26 here just by double clicking. Then I'm going to start in debug mode by clicking the little bug up here. We'll switch over to our debug perspective. And if I take a look over at my variables on the right hand side, you'll see I actually have one called empty array and I have one called filled array. Where's the stuff though? How do I see what's in them? Well, there's a little arrow next to each one, and if I click that little arrow, you can see it expands out, and I can see, there's the values. It's telling me that 8 is at index 0. It's telling me that 6 is at index 1, and so on and so forth. So I can actually use the debugger to see these contents of the array. Now let's take a look at this loop and step through this loop one at a time. This is our first trip through the loop, so you can see the value for I starts at 0, just like we told it to, right? So it's going to plug that in. What value is at position 0? It's the 8, so I print out the 8. There we go. I'm now going to increase I by 1 and check this condition to see if I need to keep going or not. That's how these for loops work. So, all right, I is now 1. I'm not done yet, so I'll print out the value at position 1. There's the next value. I keep going. I is now 2. I'll print out the value. Oops, I hit the wrong button. Sorry about that. I is now 2, and it printed out the value at position 2, even though I hit the wrong button. I is now 3. It'll print out the value at position 3. Think about what's going to happen next. I is going to go up to 4. It's going to compare 4 against the length of the array. That's also 4. 4 is not less than 4. That's a false statement. 4 less than 4 is false. So this loop is going to be done. This loop is over now, and it jumps past the end of the loop. So writing a loop in this way I am guaranteed to visit each of the elements in the array exactly one time. Does everybody see that, I hope? Put a big old star next to that one in your notes or whatever you need to do to remember it. You're going to need it on homework assignments. You're going to need it on exams. It's going to pop up all over the place. Very useful little snippet of code to have in your pocket. All right, I actually want to show you another way of doing this. So earlier I mentioned that you could use a while loop, and that's true. If you want to use a while loop, you can, but I'm actually going to show you another kind of loop today. I think it's important to show different kinds of loops. I'm going to show you an example of something called a for each loop, or you might hear it referred to as a enhanced for loop, although that's kind of, I don't like that name so much, so I almost always call them for each loops. And they start out in much the same way. Start out with the word for. The difference is that a for each loop does not have 3 parts inside of the parentheses. It only has 2 parts inside of the parentheses. The first part is going to be a variable declaration. So I just say int and then give it a name. This could be literally whatever I want, right? So I've decided to call it value. If I'm using a for each loop with an array, this is always going to be the same type as whatever is in my array, right? So if I have an array of doubles, then this should be double. If I have an array of booleans, then this should be boolean, right? So that always needs to match up. Following that variable declaration, I'm going to put a colon, not a semicolon, but a colon. For each loops use colons, and then I'll put the name of the collection or the name of the array after the colon. So only 2 parts. I declare a variable, and then I put the name of the collection. And then I'm going to go ahead and kind of do a similar thing as before by just printing out, this time, the value. Oh, whoops. I think I hit the wrong button there. Sorry. Red square will always stop if you're ever confused about what's going on. I'm making the claim right now that this loop and this loop do the same thing. Functionally, they do the same thing, which is they print out the contents of the array. How they do that is a little bit different. This one uses I to represent each index, and it pulls out the value at each index one at a time. Notice that for each loop, there's no index involved. The index is left out of the equation entirely. No index needed whatsoever. So how does it work? Well, let's run this one through the debugger real quick, and I want to show you how this one works, kind of contrast it with what we did before. I turned that last breakpoint off by double-clicking, and now I'm going to double-click on line 30 and walk through this one in the debugger to show you that the first time through the loop, instead of saying I equals 0, it says value is equal to 8. So no index is involved. The loop variable just took on the very first value from the array, and it's going to print that out. The next time through the loop, you'll see that value takes on 6, which is the second item from the array. So in this loop, every trip through the loop, I, which represents our index, goes up by 1. 0, 1, 2, 3. In this loop, it's a for each loop. The value variable takes on each value of the index one at a time. Not the index. I shouldn't have said that word. No index is involved. I'm sorry, I misspoke. Takes on each element from the array, each value from the array, one at a time. So it's going to go 8, 6, 8, 9. Yes?
And that doesn't have to be called value, right? Like that's just a variable?
Correct. It's just a variable, so I can call it whatever I want. This is equivalent, exactly the same as what I had up here just a second ago. Yeah. It's a little confusing because I'm saying value for the variable and the contents of the array. So yeah, I appreciate you clarifying that point. But yes, this is just like any other variable. I can call it whatever I want. So I'm making the claim that these two are the same. Why? What's the point? I mean, on some sense, you know, it's just like anything else in computer science. There's always more than one way to do the same thing. But on the other hand, consider, I mean, just kind of look at how much this is a bit more concise. It's a bit cleaner. If I don't need the index, then bringing the index into things can maybe overcomplicate things when I don't need to, right? A lot of people would prefer to leave the index out of the equation and do things this way if possible. But not every problem is that going to be possible. Some problems are going to require that I have access to the index, in which case, this loop is the way to go. If you're unsure whether you need the index or not, this one's probably still the way to go, in my opinion. Right? If you have to pick one of these two to commit to memory, I would say probably this one. But the professional programmers care about efficiency and conciseness of code and all of the things like that. So that's why these exist, because they do give us a more direct path in some situations than this original loop does. But they're both useful, and I'm not going to complain about either one being present in your code as long as you're using it properly. I think both are good. So if you ever find yourself in a situation trying to decide between one, if you don't have a good reason to pick one or the other, just pick whichever one you're most comfortable with. That's totally fine. Don't have a problem with that whatsoever. One final thing that I kind of want to work on with this example before we move on to our next question. So, these loops, both of them are doing pretty trivial things, just printing out the contents of the array. But this loop is going to be used for all kinds of stuff. All kinds of stuff. So I don't want you to think that this loop is only used to print out arrays. It can be used for any operation in which I need to access every element of an array. For example, let's say I just wanted to take this array that I've already created and I just want to double all of the values. I just want to multiply all the values by 2. I can do that, and it's going to use this exact same loop that I've been using. So instead of printing stuff out, I want to multiply stuff by 2. So let's think about that. I want to say filled array at position I is multiplied by 2. Right? So that'll extract every element out, multiply it by 2. Where do I want to put it? I mean, there are many correct answers that you could give, but consider this. Consider what this line of code is going to do. Remember, this is a variable assignment, so we evaluate those from right to left. I take the value on the right-hand side and I put it in the place on the left-hand side. So it's saying take whatever the current value is in the array, multiply it by 2, and then put it back into the array at the same spot. So the first time through the loop, it's going to take the 8, multiply it by 16, and then put it back in. It's going to erase that 8 with the 16, right? And then it'll take the 6, multiply it by 2 to get 12, and then replace that 6 with the 12. This will effectively double all the values in the array. So you can imagine how, any equation you could possibly think of, right, could be implemented in this way. And this is a more realistic example of what I would expect you to use this loop for on a programming assignment, for example. Any questions on this before we move to the next next topics, next set of questions, review questions? All right. So arrays by themselves can be tricky. I'm not going to deny that, but we're actually about to step it up a notch with our next set of review questions. Let's talk about two-dimensional arrays. So I would say that everything I've used so far is actually just a one-dimensional array. What does it mean if I'm using a two-dimensional array? What does my array look like if it has 2 dimensions? Can somebody describe that to me? Like a chart? I like that. Or a grid, right? I think a grid is kind of what I envision. But to be even more explicit about it, right? The arrays that I've been creating here are one-dimensional, meaning that it represents, if I was in like a math class or a linear algebra class, these would be called vectors probably, right? And vectors come in different forms. I can have a row vector or a column vector, right? So if it's one dimension, it's a line. It's a straight list of values. If it's 2 dimensions, I'm talking about a grid. I'm talking about a rectangle. So my 2-dimensional arrays are going to have rows and columns. They're going to have 2 dimensions, right? Rows is 1 dimension and columns is the other dimension. It's going to make a rectangle. It's going to make a grid. So let's talk about how that affects the code that we write. If I want to make a 2-dimensional array, let's use doubles this time because I've been using a lot of ints today. I want to mix it up. Let's do doubles. A one-dimensional array of doubles is going to look like this. A two-dimensional array of doubles is going to have another pair of square brackets after it. So I look at this and say, oh, that's 2 dimensions, rows and columns, right? Otherwise, we're going to kind of plug along just as we did before. I'll call it 2D empty. I'll make an empty one this time. And I'm going to use the word new. We already talked about that. Double bracket, bracket. But now, just like before, I have to put numbers in these brackets. Where the numbers, does anybody know what the first number represents? Or the second number? I'd take either one. First one is the rows. Second one is the number of columns. So I'm saying I want to create an array of doubles that has 3 rows and 4 columns. That means that I know there will be 12 items total, right? 3 rows of 4 columns should be 12 items total in this 2-dimensional array. Rows always comes first. Always, always, always. When you're looking at those 2 brackets, the first one is always the rows, the second one is always the columns. Always, 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 always. Let's talk about making a filled array. Let's say I want to make a Boolean array. Filled 2D. Sure. So before we saw the curly brackets. That was enough for a one-dimensional array. But for a two-dimensional array, we're going to have brackets inside of brackets. So I'm making an array of Booleans, which means I can only use true and false here, right? But I can say true, false, true, comma. And then you don't have to do it like I'm doing, but I generally do like to shift it and make it look very much like the 2D array that I'm trying to represent. So the outer brackets here are for the entire array, and then each pair of these inner brackets, that's one row. So this is actually the 0th row, right? Because we start from 0 still. So this is row 0, and this would be row 1. So I have 2 rows and 3 columns in this array that I've just created. Everybody see that? Right? Okay. So then, how do I access data within a 2-dimensional array? I mean, if I want to grab this false value, for example, how do I do that? Well, I need to say the name of the array. And before, I could say, you know, bracket 0. But that's not enough anymore, right? I have rows and columns. I need two indices to access a value. I need to tell you both a row and a column, and I've only told you one number, right? This is the row. Row always comes first. So I'm saying go to row 0. If I want this false, which column is that? It's 1. It's 1. This is column 0. This is column 1. Yep. So I'm saying go to row 0, column 1, and get me whatever that value is. Maybe we want to print it out. We can put it inside of a print statement. Uh-oh, what happened? You destroyed my statement. That's okay. I fixed it. Okay. So for a 2D array, just one index isn't enough. I have to specify both a row and a column. So if we run this now, we can see that, oh gosh, I'm in debug mode. I'm sorry. Let me turn the breakpoint off and hit the red square and click the Java to go back to the Java perspective. There we go. There's the false that I was hoping would come back out. And the same thing goes in reverse. If I want to change a value in a certain position of the array, right? If I want to change that false to be true, then I have to say 2 indices, right? A row and a column. So now this will take the value of true and put it in, you know, that same position we've been working with, row 0, column 1. All right. Everybody with me so far? So let's talk about traversal, because that's important for two-dimensional arrays as well. Because again, let's say I wanted to see the contents of this array, right? I can't just print out the whole collection. I have to go through and touch each one at a time and print it out one at a time. So it's going to start similarly to what we had before. It's going to start similarly to our one-dimensional example. I'm going to make I equals 0. I is less than filled 2D dot length. Well, wait a second. What does this mean? For a one-dimensional array, that seems pretty obvious. It's just how long it is, right? But this isn't a one-dimensional array anymore. It's a two-dimensional array. So what does this mean in a two-dimensional array? Does anybody know? Dot length. So dot length for a two-dimensional array. This is tricky. This is actually one of the trickier parts of dealing with two-dimensional arrays. This is going to tell me the number of rows. Not the total number of elements, but just the number of rows. All right. So what that means is that, if I can type, what that means is that when I write a for loop that looks like this, I is going to start at 0, and I is going to count up once for each row. In my two-dimensional array, I even like to kind of remind myself, right, this loop is for the rows. I put a little comment out there. This one is for the rows. But that's not enough. For a 2D array, we just talked about how I need two indices, right? I need rows and columns. So that means that I need another loop inside of the loop that I just had. What's it called when I put a loop inside of a loop? Anybody remember? It's a nested loop. It's a nested loop. So I'll say for j is equal to 0. J, I need an int up front there. Int j is equal to 0. J is less than, now here's where we run into another little thing we need to think about. I can't say filled 2D.length here. I just told you that this represents the number of rows. I'm not trying to do rows anymore. I'm trying to do columns. So how do I get the number of columns back out? That's a very tricky one. Let me show you. I'm going to say this. Let's think about what this means. Notice that there's actually only one set of brackets here. You might be like, well, it's a 2D array. You said we can't do that. Hold on a second. I'm saying pull out row 0 and tell me how long that row is. The length of a row is the number of columns, right? If there are 7 things in that row, then that means there's 7 columns in my two-dimensional array. Yes?
So you could put any number there, or as long as it's like a valid row number?
Yeah, so I can put any valid row number in here. In practice, we almost always use 0 because if it has any rows, it's guaranteed to have a 0, right? It's actually, this is getting a little bit into the weeds. It's possible to make an array with 0 rows in it. It's a little weird. You're not going to see me do that. In practice, most arrays have at least 1 row in it, so this is considered safe. Using anything other than this, even 1, it's considered unsafe, right? What if there's only 1 row in it? Then this is wrong. So always 0 there. Always 0 there. Or the other one that I would accept actually is I. Kind of like that too, right? Kind of like that too, because this is guaranteed to visit each row. One other thing I want to point out, it is possible to have rows that are different lengths in a 2D array. You're not going to see that in this class. So you can very much safely assume that every two-dimensional array you see in this class is going to be rectangular and all of the rows are going to have the exact same length. Some students who've done programming before are aware of this fact, so I always like to clarify that just to make sure. Yes, it is possible to have different length rows in a two-dimensional array. You're not going to see that in this class. That's above and beyond what we're going to cover. But if you're interested, you're welcome to take a look, and I'd be happy to chat with you about it in office hours or something sometime if you want to go over it in more detail. But this will get us through the number of columns. Okay. And now let's just try and keep things simple. I just want to print out my two-dimensional array, right? Just want to print out the contents of my two-dimensional array. So last time we did something like this. where I could, this time, instead of saying just I can say I and J, right? I represents what column I'm on, and J represents what row I'm on. That seems okay. Let's try it out. Let's try it out and see what happens. I'm hoping that I see this two-dimensional array, and okay, here it is, right? That's it, but I'm not super satisfied with this because it doesn't look rectangular, right? It doesn't look like the 2D array. I can't see the rows and the columns. Can't see the rows and the columns. For example, you know, these three values are on the same row, so it would be nice if I could see them on the same row, and then these three are on the next row, so it'd be nice if I could see those on the next row. We can actually do that, right? That's a thing we can do. I think it's useful to talk about. Let's first off take a look at the fact that, okay, this says print ln. That's why it's printing a value, moving to the next line, printing a value, moving to the next line. If I don't want that to happen, then I can just take that off, right? And now, if I run this again, it'll say, okay, all right. You might think, that's worse than what we had before, but hold on, we're working on it. We're working on it. I can see that these three values are on the same row, right? That's good. You might be saying, oh, they're all smushed together. I can fix that. I can fix that by using a little bit of concatenation over here. Concatenate space on the end, right? So that should hopefully, there we go. That's a little bit nicer for me to look at. But now I need to figure out how to get this to go down, be on the next row. So where in this code do I know that I'm at the end of a row is really the question, right? It's a tough one. It's almost always a stumper for students when we're talking about 2D arrays. Consider, this loop represents the rows. So if I want to know when I'm at the end of a row, then the end of this loop means that I am at the end of a row because this loop represents the rows. So if I want to move down at the end of a row, I'm going to come down here, right? Notice where my cursor is. And I'll put in a print statement, a print line statement that's blank. I just need to move down, right? I don't need to print anything. I just need to move down. So the ln will hopefully accomplish that for me. Let's run it and see. Oh, there we go. Now my two-dimensional array, when I print it out, actually looks like the rectangular two-dimensional array that it is. I think that's important, especially if you're trying to figure out how to solve a problem in your code, right? It's important to be able to see things exactly as they are. But that's not good enough. This is so important and such an important piece of code that I would like to do what I did with some of these other ones and run it through the debugger. I think it's very important to understand how we're moving through this array with these loops. So are all my other breakpoints off? Yes. Let me set a breakpoint here on line 44 where I'm using my nested for loop. Start it up in the debugger. Okay. So here's my array. You can actually see the two rows in the array, right? True, 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 false, false, false. But I'm more interested in what's going on with these loops. So here I am at the first loop. This is what I would call the outer loop, right? So the outer loop is controlling the rows. It says I starts at 0, and okay, there we go. I is at 0. I'm now on my inner loop. My inner loop's controlling the columns. And it also says J starts at 0. Okay, that makes sense to me. I is going to start at 0. J is also going to start at 0. So in my mental map, my mental image of the array, right? Here's my grid. 0, 0 is the top left corner. Always. 0, 0 in a two-dimensional array. In my brain, top left corner, right? Where am I going to go next? I'm going to print out the thing in the top left corner at position 0, 0. There it is. Where do I go next? Well, think about what the code's telling us. This loop is inside of this one. So before this loop can update, this loop needs to run through in its entirety. It needs to go through the whole thing before I change this. Or in other words, I is going to stay constant while J changes more rapidly. J is going to go 0, 1, 2 while I stays the same. So we can actually see that, right? The next place I go to, notice that I is still 0, J has now counted up to be 1. So I was in the top left corner. I moved one spot to the right. I'm on the same row, row 0. I moved one column to the right. J is now 1. So I'll print out whatever is in that position, 0, 1. I'm still not done yet. This inner loop is still not finished. So I'm going to do it one more time. You can see that I is still not changed. I is still 0, and J is now 2. So in this example, I'm at the upper right corner. I'm at the end of the first row, row 0. I'll print out that last value from row 0. And now I am done. I'm done with this inner loop. In fact, I'm done with the entire first row, which means I need to tell it to move down and get ready for the next row. So it's a little hard to see this because I'm just moving down, basically. It's not actually printing anything. You can see there is a little blank space there. But now look at where we're at. I'm back up to the outer loop again. Now, it's going to go up to 1. And J, look where we are. We're in the inner loop again. We're going to run this entire inner loop over again from the very beginning. So J is going to be 0. I'm now at row 1, 0. So now I'm all the way on the left side, but I'm down, right? I did this row. Now I'm down here. And I'm going to go across that row just the same as I did with the first row, with I remaining constant and J counting up. So now I'm at 1, 1, finally 1, 2. I move down again. This one is a little unnecessary because you and I know that we're really done at this point. There are no more rows, but it's not hurting anything, right? It's not actually damaging anything or getting in the way. And finally, this loop's gonna, bump I up 1 and realize that, oh, we're out of rows now. I'm done. I'm actually done. And I've exited that. But the big takeaway here, the thing that I really hope you get out of this, the way that these nested loops are set up, how are we moving through our two-dimensional array? Starting at the top left, going down the row. Then go down the next row, go across. It's just like we read a book. It's just like we read a book. Start at the top left corner and go across the rows and then go down. Just like we're reading a book. And that's intentional. It's very much intentional. That's how we as humans are kind of trained to view data, right? Could I do it differently? Could I make it go down the columns instead? Absolutely. And maybe that's beneficial in some situations. In most situations, though, this is going to work just fine. So just like you did for the other one, when I showed you how to traverse a 1D array, I think this is also worthy of a big old star in your notes. Whenever you're working with a two-dimensional array, I hope in the back of your mind you're thinking, I might need that nested loop structure at some point. Is it a guarantee? No. Definitely not a guarantee. There are situations in which you don't need this. It would be considered overkill. But they do go together very often. You will see this on assignments, studios, exams, etc. It's a very common coding construct. So yeah, are there any questions? I know it can be a little mind-bending. I'm happy to explain something again. I'm happy to debug again, answer any questions. What can I help you with? Yeah?
Is the reason it prints out like true for the top one because we would wrote in question 6
Yeah.
so if you had not done that you print true false.
I switched this one to be true, yeah. But if I just come down here and comment that line out even, right, and run this guy again, we should see our original array. Yeah. Good observation.
I just wanted to check.
No, I totally understand. Yeah, totally legit. I get it. Any other questions? Anything else I can help out with before we move on and do some other stuff? We have about 20 minutes left in class. Are there any examples from the prep work that you would like to see me go through? I know there's all these examples. There's exercises here too. If you want to see me go through any of these exercises, I'm happy to do so. Just want to see if there were any that anyone from the audience was hoping we would take a look at. If not, I have some that I'm happy to go through. Just want to give you an opportunity first. I'm not seeing any hands. Okay, that's all right. Then let's go ahead. I brought some exercises with me that I'd like to go through with you. So let's go ahead and do those for the next for the time that we have remaining. I'm actually going to start, I think, with this one. I don't know that we'll have time to do all three of these, but we definitely have time to do at least one of them. So I'm going to start with this one that wants you to write a program that asks the user how many random numbers they'd like to be generated. You should then generate that many random values between 1 and 10 inclusive, storing them in an array, and then display the contents, display the random numbers to the user. So the hardest part of this one, I mean, the arrays are a little tricky, yes, but actually I think the hardest part of this one is figuring out how to do this. But you actually already know everything that you need in order to pull this off. It's more just a logic problem, right? Figuring out how to put those pieces together. I'm going to give you a few minutes. I'm going to come around. Let me know if you get stuck. Talk to your neighbors. You don't have to work on this by yourself. Talk to your neighbors. Work on it together. Collaborate. I will walk through this solution around, I don't know what, 5 or 10 minutes or so. I'll call you up to attention. Then we'll walk through this one to wrap up for today. I'll be around. Let me know if you have any questions. Okay, so you'll have to click on that box and then just type new or something inside the box, the text. And just type the word new or something. Oh, don't delete it all. No, 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 no. And I'll just type it again, so I can start over. You check that box, you'll never have to paste that in again. Just say no. Oh, yeah. It's a security question. Now, click in the box, and don't delete it, just type the word new or something. Okay, thanks. Next. You need to use the smart import. Yeah, it's on the first screen. It says get import with smart import or something like that. Yeah, you're almost there. You're good. Thanks. It's okay.
Oh.
Yep, yep. Okay, so just click in the box and just type the word new on there or something. Anything. Yeah, right. Sorry about the confusion. What's up? Yeah. So go to Eclipse and do import. And then do the smart import. Yeah, that one. And then just follow the same steps as normal. Make sure it works. So click in the box there and just type the word new or something. Oh, can you control Z? At the very end, leave everything in there and just type new. Yeah, sorry it was so confusing today. Okay. Do the smart import. Do that one. Everything else will be exactly the same. Yes. And then click in that box there. Inside there and choose. Just type new or just make it a little bit yes. It's 1 or 2 minutes before I'm going to start walking through this one.
It's a random value between one and ten, so.
Yeah, just
Okay, okay.
yeah. All right, everybody. I know you may not be done with this one yet, but we're almost out of time. We only got about 10 minutes left, and I want to make sure that I show you the solution to this. Walk through this one before you leave here today. So if you didn't get done, that's okay. Let's talk about it. Let's see if we can figure this problem out. The first thing that it asks us to do is to ask our user how many random numbers they'd like to be generated. This actually has nothing to do with arrays at all, right? It's just a good old scanner. So hopefully that part wasn't too tricky for you. I'm going to go ahead and create my scanner. I know how to do this because it's one of those things that I've done 80 million times over my life. But if you need a refresher, if you don't remember what these magic words are, that's totally okay. Just go grab it from a different file. That's fine. It's absolutely 100% okay. Not a problem at all. Do have to remember to import it once you've got that line set up. And now we should be good to go to prompt our user and read in a value. Again, this is all kind of review, so I'm going to go through it a little bit quickly here. Get to the good part. Come on now. Where is it? Okay. Sometimes my fingers don't do what I want them to do. All right. So this all is basically a review. Nothing too crazy going on here just yet. At least I hope not. The next thing is that we need to create an array, since that's what we're talking about today, that can hold this many things. Right? We need to create an array that can hold that many things. And we have two different ways of creating an array. I can either create an array that's empty with the idea I'm going to fill it later, or if I know what I want the values to be, I can create an array with and just fill it with those values automatically. But since we're doing random numbers here, I think option 1, creating an empty array and then filling it later, is the right one. So let's create an empty array. I'll just call it array, I guess. That's not the best name in the world, but it'll do. And inside of the brackets, I'm going to take whatever value they typed in, right? So this variable, I'm actually going to just plug it right inside of the brackets. So if they type 10, then this will make an array of size 10. If they type in 5, then it'll make an array of type 5, right? That's kind of the goal here. All right. Our next task is to generate that many random numbers. So if I have, if they typed in 10, I need to generate 10 random numbers. And if they typed in 100, I need to generate 100 random numbers. What am I going to use to perform that very repetitive task for me? A loop. Yeah, definitely. For loop will work, while loop will work. Take your pick. I think a for loop works really well here. I can say int I is equal to, I think starting at 0 is good for the reasons we've discussed, right? They're going to go into an array. The first value I want to go into the array at index 0. The second value I want to go in at index 1, and so on. So I'm really kind of writing that loop that I showed you earlier, although I think it's interesting to point out that I could do this, right? I is less than number. I think that's fine. Or if I want to do I is less than array.length, I think that's also fine. I think those are both valid options here, right? It's kind of a potato situation. Either of those options will work for us, and then it'll say I++. And now I need to start generating random values. So this is, I think, arguably the trickiest part of this whole exercise. I want to generate values that are from 1 inclusive and 10 inclusive, and I want them to be ints. I mean, they don't have to be ints, but for the purposes of this exercise, I'm going to say I want them to be ints. Okay. I think most of you probably, hopefully remember that math.random is what generates random numbers for us. But what kinds of random numbers am I going to get from this? Doubles from what to what? 0 to 1. Be a little bit careful. Can I get 0? Yes, I can get 0. Can I get 1? No. So 0 is inclusive, 1 is not. I can get 0.999999999. I'm not going to get 1, ever. 1 is not something that this will give back to me. So 0 is the smallest one. 0.9999999 is the biggest random number that I'm going to get back. That's not what I want. I want numbers between 1 and 10. Well, we can get there. We just need to do a little bit of math. So think about, okay, how many different random numbers do I need to generate? Or in other words, what's the range? What's the range? I would argue that the range is 10, although I think it's worth kind of thinking about this mentally in terms of what's going to happen here. For both the lowest case of math.random and the highest case of math.random, what happens? If it gives me the low end, if it gives me the 0, right? 0 times 10 gets me 0, right? If it gives me the high end, if it gives me 0.999999999 repeating, that times 10 is going to give me 9.9999999. 9999999 repeating. So right now I've managed to get numbers between 0 and up to, but not including 10, right? Not inclusive of 10. So I'm almost there. I actually need to do just a couple more things. One thing I need to do is, if I'm interested in ints, I gotta chop that decimal off. How do I do that? So somebody said rounding. We gotta be a little bit careful. I didn't say round. I said I want to chop it off. There's a difference. Yeah. Cast it to an int, right? Casting it to an int does not round. It actually just chops it off. So if it's 10.99999, I get 10. And it turns out that's actually important. Rounding would shift this equation a little bit, at least in terms of what I'm going for. So I think casting it to an int is actually what we want to do. I'm going to wrap this whole thing in parentheses just to make sure, right? Because if I cast this to an int, what am I going to get? If I just cast math.random to an int, I'm going to get 0 every time? That's not what I want. You got to be careful. Careful with those order of operations. Always use parentheses to help clarify if you need to. So we're almost there. If this gives me 0, then 0 times 10 is 0. And if I cast that to an int, it's still 0. If this gives me 0.999999, then I get that times 10, which is 9.9999. And if I chop the decimal off of that, then I just get 9. So this expression is going to get me values between 0 and 9. I'm so close. I just want to get to between 1 and 10. So I'll just come over here and I'll add 1 to it. All right. Once I have randomly generated that value, I need to put it into the array. So I'll say array at position I is equal to that value. You could actually do all of this in one line if you wanted to. That's totally okay if you did. I think I did it in one line last section, actually. For this section, I decided to break it into 2 for some reason, but that's okay. And then I want to check and make sure that it works. So I'm going to come down here and actually put in another loop that just prints out the contents of the array, just to check and make sure that we're actually getting appropriate values. This is the exact same for loop that I have shown you at least a few times today. It's just going to traverse the array and print out the contents. Let's try it out. Let's see if it works. Let's say I want 10 random values to start with, and hopefully you'll see, all right, wow, 3 10s in a row. And then some 9. Well, I mean, okay. Seems to be working. I don't see anything less than 1 or greater than 10, but let's really test it out. Let's do 100 random values, right? I see 1s, I see 10s, I see every number in between. I don't see any 11s. I don't see any 0s. That's a good thing, right? I've succeeded. But wait a second. I think I would like to kind of make it clear that using this formula, I can generate random numbers between any range, any values that I want, right? I just have to change this number and this number to reflect the random numbers that I want to generate. So if I'm generating numbers between 1 and 50, well, this becomes 50, right? And now I'm generating numbers between 1 and 50. If I'm generating numbers between 10 and 20, actually that has the same range, right, of 10. I just need to add 10, right? It shifts the whole thing up by 10. I can do negative numbers by subtracting instead of adding, right? Or, let's say I want to generate numbers between 50 and 100. The range is 50. And the shift is also 50. I want to shift from 0 up to 50. So if I run this, I should hopefully now see only numbers between 50 and 100. And in fact, that's what I see, right? Nothing below 50, nothing above 100 is going to appear in this set. So I can generate random numbers in any range that I want by using this formula and manipulating this value, which is the range, and this value, which is I usually call the offset, right? Instead of starting at 0, I want to start from 50, so I offset it by 50. It's a really useful thing to know, and that's another thing that's probably going to show up on some future homework assignments. Hint, hint. But that's it for today. We're out of time. I hope this was useful for you, and I hope you have a great week. I will see you in the labs on Wednesday.